We'll get to that. And then talk a bit about the future trajectory of C++, which is what ties in with the title of the talk. And there'll be just a little code in there as well. But I think it's important to understand, in addition to the style information that Scott's going to talk about, the deep compiler internals that other speakers are talking about, language features and guidance, to also see how we are at an inflection point in C++ and how that change affects us and what we can expect. So I also promised that today I would give an update on Visual C++ conformance progress. At the Build conference 2 and a bit months ago, we laid out a map for planning milestones, what you can expect for conformance from Visual C++. I promised to give a short update, so I'll do that, but it'll be short. And then we'll switch back to the main event, which is C++ on all platforms. So let me start with that roadmap update. In June, I showed this slide, and these are the first steps to the remaining C++ 14 full conformance features, because we're targeting not just 11, but 14, which completes C++ 11, and we're taking that as a whole bucket of features and doing them in the order that delivers the most value soonest to people. So off to the left of this slide are all the things we already implemented in VS 2010 and 2012. This is what remains after VC 2012. So we shipped the preview in June. So I updated from today. That's the one change I made to this slide. Instead of today, which was in June, we shipped in June that first set of features. And we told you that the RTM version of Visual C++ would include another set of features, including 4 C99 features when compiling in C mode. But the top half is further C++ conformance features. And we said that that would be later this year. I happen to know that when you say things like later this year, people assume you mean December 32nd. So let me correct that, because I also said we'd give you more information when we knew it ourselves. And what I can tell you today is that we will give you an update to that will be available this month, sooner rather than later. And you will be able to use that product with a Go Live license to use all of these features from Visual C++ this month. Now, so we're glad about that. But wait, we still have more to do. Because notice that white part of the slide? We also said, here is what remains for full C++ 14 conformance, including not just C++ 14, but the whole C++ 14 wave, which includes the 3 technical specifications that the Standards Committee is expected to issue in the next year, which includes file system, which we already ship a version of, and the beginning networking library, and also concepts that Bjarne talked about yesterday. I think it is great that implementations, and I'm looking at the other implementers in the room, are competing on who can implement not just C++ 14 first, but concepts first as well. This shows the attention and the quality of the proposal and the attention being given to by the community. And there's also a feature in the middle bottom that is one that Microsoft is developing, which is async and await. And we are also going to target bringing that into Visual C++. Now, I want to focus on these middle 2 columns because I said, okay, what's next after the next release, 2013, goes to market? We're going to do another out-of-band community tech preview, compiler preview, and it's going to be some subset of the features in those 2 columns I said, some subset, and it'll be sometime after RTM of Visual C++ 2013. Well, we told you we'd let you know more when we knew more, and as of today, here is what we know. So here's an update. Post-RTM means that we are going to ship it this year. Some of you anticipated that meant maybe in early 2015. We're going to ship that this year. And it is going to include nearly all of the features, including the high-value features in those middle 2 columns. So the cells in green are the high probability features to get into that CTP. And there's a couple more that we're trying really hard to get in, and that we hope will also be in the CTP, but they're not quite at that level of certainty yet for me to tell you that today, but we'll keep you updated. In fact, Jonathan Caves is in the room. Jonathan, there you are. Would you stand up, please? Jonathan is one of our longtime compiler writers. Now, this is interesting because, please stay standing, because many of you Don't know him. He doesn't blog. He doesn't give many talks. But did you notice that he already was getting applause from people like Bjarne, who've worked with him in the Standards Committee for many years? I just want to say thank you, John, for implementing lambdas in the first place in VC 2010, and now for showing me the first running demo of generic lambdas yesterday. So he is the man. Thank you very much. And John, we're hoping you can pull that rabbit out of the hat and turn that yellow into green. So thank you very much. If not then, it'll be soon after. So thank you, John. And if you put this all together, again, excluding the features we already shipped up to VC 2012, this is what remains. Within 12 to 15 months after shipping VC 2012, we will be shipping in either release form or CTP form most of the remaining work for C++14, including, I believe, all of the high-value features and some of the most difficult ones, including constexpr. That was a really hard one because that's where we had to actually change the way our compiler operated in order to be able to work on the ASTs required by that language feature. So there's still more to be done after that, but that's an update as to where we are and what to expect in fourth quarter in a preview form this year. So let me now switch, and we'll talk about C++ again for the rest of this talk on all platforms and standard C++ that works on all compilers. And first, let me give you a quick update on what's been happening with ISO C++. I've shown this slide before. Over the last decade plus, 13 years since 1998, we've shipped a couple of specifications. Library TR1 was the big one. And then finally, in C++11, we shipped a new standard. Now we have switched gears. Notice there's a bit of a lag as the pipeline starts to fill up, but we really have switched the way that we work. Between C++11 and C++14, there's still a gap because now we're starting to see the fruits in 14 that are coming in the form of the library specifications and the language specifications in addition to the standard. So we're decoupling features so that instead of one monolithic release, we can release features as they're ready in technical specifications to get experience with the feature with the goal of merging them back into the main standard. We all know what branches and trunks are. And this is really helping us deliver more sooner. And we're very excited about that. But this is really a generational shift in the way C++ operates. Just in the last day or two, I've forgotten, I'm sorry, who it was who related this to me. But one of you was telling me that you had been talking to another person who knew about C++, but had been away for a while. And that person said, "Oh, you mean there's a new standard? I thought C++ was just C++. Static, unchanging. It's this thing that was invented who knows how many years ago and is just what it is." We have switched from static. We are now transitioning to dynamic. And that really shows how C++ is a living language and one that continues to change. Now, that doesn't mean we're taking changes on the size of C++11 every couple of years. That would be destabilizing. What we're doing is we're sort of switching from punctuated equilibrium to gradualism, and we're getting to where we're delivering a changing and evolving language in a way that preserves compatibility, but is very much alive and is always fresh and new and able to adapt to new demands in the marketplace. This is really exciting because it's a change from the way that C++ has been in the past, in the standard. And the standard is the center in many ways of C++ in the world because it defines what the portable part of C++ ought to be. Now, the C++14 standard, if you go back here, that's on track for next year. Notice the C++14 minor release with some additional features in the new standard. We are now at a place where this summer we evaluated and sent out for international ballot the first and primary CD, committee draft. This is the primary round of international balloting. When we do this, all the nations go, and they have about 3 months to go and talk with their experts in caucus and fill out big, long bug reports or feature requests, or here, you misspelled things here, everything from editorial to substantive. And then you get all of this global 3 months worth of effort. It is a big package dropped on your doorstep, and you get to have a ballot resolution meeting or 3. And when we did this twice with C++11, the CD and then the DIS, which is sort of like the final CD, those were the two main rounds of international balloting. And just to give you a flavor, I know that most of you aren't standards committee members, so this is more showing you sort of what's going on inside, so you get sort of a sense of the process, and also a sense of the comment volumes we've had in the past. We've had between 500 and 600 in each round, international comments to work through. And we're required to have a written response for every single one of them. Might be won't fix, or by design, but often it will be, okay, what if we change it in this way? Will you change your no to a yes? That kind of thing. And, it takes a while to go through 500 or 600 comments. 3 weeks ago, the committee draft for C++14 came back. Who wants to guess how many comments? Who isn't in the committee and already saw it in the mailing? Who wants to guess how many comments are in there? What would you expect? 1,000, 1,200, okay, yeah, because you're used to graphs that go this way, right? It came in at 85. It came in very clean. So thank you to all the committee members who worked hard to bring that to a high quality of release. Now, full disclosure, I then found out that apparently Canada had 30 comments that might or might not have squeaked in, so there might be a few more. But there is a large difference, and a lot of them were C++11 comments. So a large difference, not just in the cadence with which we're shipping, because sometimes when you ship more often, quality does this. Quality is doing this. And I think that's actually an effect of shipping more often, because you don't have the patient open as long. You don't have as great a chance to destabilize. This is good for the standard. It is good for the community. So we look forward to having that ballot resolution in about 3 weeks in Chicago. Several of us will be there, and we'll be working all night and day talking about these comments and continuing work on all of these things. So that's a quick update where we are with C++14. It looks to be really solidly on track and in great shape for release next year. So it's still on track, and that's still what we expect it to be. Let me talk about what I said at Going Native last year on this stage was the biggest drawback, the biggest problem with C++ today. And you remember I took a poll of a few. Like, what do you think that C++'s biggest problem is? And several people said, oh, this language feature or that language feature, or just the language is too complex. And I didn't agree with that then, and I don't agree with it now. The reason is, if you look at C++, is it a more complex language because of C compatibility in particular and because of wanting flexibility? Sure. Is that important? Not really. I'm going to continue to give you data points in the next hour to show why that is demonstrably not true. But for now, suffice it to say that many people have come up with languages that compete with C++ on C++'s turf, meaning performance, efficiency, native code, and mainly cleaned up the syntax. And have you heard about many of them? No. And if that was a serious problem, they would have taken off. But that problem itself, by itself, is not enough to justify, is not a big enough problem to solve to switch away from C++. C++ itself is getting simpler, and in ways that I think will surprise you as we get to it a few slides from now. So the problem with C++ is not its complexity. Clang and others have shown that you can write modern C++ parsers that deal well with the complexity of C++ and still allow things like refactoring and tools and that kind of thing. But libraries are important. So I showed this slide as well. If you compare the C++98 and C++11 standards, and I'm showing TR1 in between, the library TR that we shipped in the mid-last decade. If you go just by spec number of pages, yes, we grew the language, but not nearly as much as most people thought. Even with lambda functions and auto and all those things, the language really grew incrementally, maybe 20% or 30%. The library nearly doubled. Nearly doubled. This is a great start. But now compare that with other languages. So I teased you by saying last year, okay, so how is C++'s complexity compared to, say, C# or Java? Because everybody knows those are simpler languages, right? Well, if you compare by number of words, the specs of Java and C# and C++, and these were the data points I used last year, they're remarkably similar because they have remarkably similar feature sets. The specifications are of about the same complexity. The languages are of about the same complexity. What is a big difference is the libraries. Now, more does not mean better. Let's be very clear about that. Just because there are more libraries does not say anything about quality. It does not say anything about how monolithic and release unfriendly they are, because some of these libraries and in other languages that have monolithic frameworks have actually found that to be a great handicap, because they get progressively more difficult to extend and maintain and release, where they start to reach a certain complexity in the library, never mind the language, where they can't be serviced and they can't be as alive. And part of that is the couplings, the interdependencies, which we have good tools to deal with in C++, but some of them are still there. More is not necessarily better. There are drawbacks to a large library. But one of the very important things that many other languages, and you could include Python here with PyPy and others, is that if I'm a book author, and I want to teach people a technique in my language, or just teach the whole language, or make some point, a style guide, whatever it is, I can just assume people have got all that. And I can just use it in my example. With C++, we got a decent start at a standard library. In C++ 98, we nearly doubled that in 11, but we really need to do more. And Bjarne himself has said that. Here's a quote from a few years ago from his Hoppel 3 paper, which, by the way, itself was a landmark. I don't believe any other language has ever had 3 history of programming languages papers. Is that still true? Did I get that right?
I have 2, but you can add C.
OK, you have 2, but you can add C. So with Hoppel 3, the fact that C++ has been around and important for so long, Bjarne has to continually write about it and tell people, here's what the latest stuff is. Here's what we're working on. Here's where we're going. But one of the things he made was, we've got all these library proposals at the time in the middle of the C++ OX process, most of which ended up being accepted. But he said it's still not quite the ambitious and opportunistic policy that I had hoped for in 2001. And I remember that meeting where you had said that. Because even if we do this, we're only doubling the size of the standard library, and we have a long way to go. So the goals I proposed, and this was very early thinking when we were here a year and a half ago, and I want to give you an update now on how that has firmed up, how that has become crisper as we as a community have been working on it. I set a goal that we ought to have a large set of useful and current libraries. They should be available on all major platforms. They should ideally be shipped with and supported by C++ implementations. They should also work well together, and loosely coupled, but still work well together. Now, as a minimum bar, I would be happy if they were de facto available like Boost is, but Boost is probably the only exemplar in that category, core of Boost, where you can write a book and just assume people have access to it. Ideally, they would actually be part de jure of the C++ standard. That's what would achieve everybody gets it in the box, right? So then we said, well, where are you going to find all these libraries? They already exist. Let's find a way to bring them into the standard. So here's what's new. It's become clear that there's a nice distinction between de jure standard libraries and de facto community libraries that are so widely available that you can just assume people have access to them. I'm going to talk almost exclusively about the de jure part. I'm going to leave de facto for next year, but there will be a slide at the end on de facto. But we've been focusing mostly on what can we bring into the standard that is horizontal, that matters to everybody. De jure libraries, what's in namespace std? What are horizontal libraries? They're not specific to one application domain that really are broadly useful, something that's not for 1%, but something that's for a 70%, and it's always a different 70% of C++ developers, and that therefore, by being in the standard, will ship in the box with every compiler. You can just assume it's there. So there's 2 parts to this challenge. The first challenge is to take what we have already, this wonderful asset, the world's most flexible and efficient library building language, and say, you know what, that's not enough. We want to cannibalize ourselves. We want to compete with ourselves. Why? C++ 11 is so much better than 98. 14 is better than 11. Let's obsolete it again. Let's keep doing that. But in particular, not just adding features, but making it better for library building. And then the second part is key, and then bundle more broadly useful community libraries in the box. And so when we had that discussion here on a Friday, the Going Native ended last year. A lot of us got on the plane to Kona to the standards meeting, left on Friday, flew on Saturday, Sunday, and then on Monday we discussed this very thing in the standards committee. And one of the comments Bjarne made in full committee 3 days after Going Native last year here was, "This is great, but who's going to do the work? Are you just going to ask everybody who's here already just to work harder? They're already maxed out. We're only going to make progress if we somehow find a way to involve new people." We have involved new people. Here's an update to a slide that I've shown you. ISO C++ committee attendance, you always get a bit of a spike when you just are shipping a product or completing a product. So I have tentative numbers for Chicago in 2 or 3 weeks. It looks like we're going to break 90. Don't know if we're going to break 100 again, but you can clearly see the trend here since we talked about this last. But where are these people coming from, and how are we organizing them? Let me give you some insight to that, because even though you're not part of the standards committee, this directly affects you. It directly affects understanding where C++ is going, who is driving it there, and how you can participate, and how it's going to affect the way you write code. Instead of having one Jupiter, that's not a Death Star, I promise you, of the standards committee that had billowing clouds, is kind of opaque. Nobody's really sure what goes on under there, but every so often it's ejected. That is an okay model. But you know, there are at least 4 major moons around Jupiter, and then plus another dozen more. So we have at least 4 substantially sized subgroups, and now almost a dozen in total. I'll tell you who they are, but we're into this satellites model, where we have additional groups that operate independently, but still are gravitationally bound to WG21. And they're organized as follows. Now, if I were to show you a snapshot as of 18 months ago, as of Going Native last year, this was the C++ Standards Committee. There was the full committee, but they were broken into 4 subgroups. Core and library, which owned the specifications for the core language in the library, and evolution, which owned evolution and new features that involved language impact. That's why I've put them in the same color as core, because they're on the language side of the house. Usually if new libraries came along, the library working group would handle them, as well as routine processing and wordsmithing and maintenance. And there was already one group that was focused on concurrency and parallelism that had already been spun off, ejected into orbit around from the evolution working group. So at the Kona meeting, the week after Going Native from last year, we decided to try something. ISO has this structure that we had not exercised before that's called a study group. And let me tell you what that is, because this is mind-numbing, Geneva-oriented bureaucraties, but it's also useful. A study group basically is just a group of people, usually on a particular domain or question, which are directly associated with the standards committee, but operate independently. So they're appointed by the convener, which is myself, and so I'll make sure that there's enough critical mass for people who want to work on it so it's credible. It's not just going to be there in name only and then founder. And I make sure that there's a suitable chair who is qualified to drive that effort. And so we actually, at the Kona meeting, a week after Going Native last year, we created the first 3 of those. So I appointed SG2 for modules with Doug Greger as the chair, SG3 for file system, which had Beeman Dawes of Boost. Many of you know that name. He's very famous as the chair. And SG4 networking, which is led by our committee secretary, Kyle Klepper. And now each of these were able to work independently. And so was SG1. So I converted concurrency and parallelism also into an SG. One of the things that happens when you have this separate group that can meet on its own and still be under the ISO antitrust umbrella, you know, where companies can still get together and talk about stuff that otherwise wouldn't be allowable except in a standard setting organization environment. Once you have that, you start to attract mass. And C++ has an enormous amount of dark matter. People who don't swamp blogs and forums. People who don't vomit on /dot and Reddit and other places, but who are doing great work quietly and essentially building our civilization and infrastructure. And but aren't that vocal about it necessarily. There's all this dark matter. So as soon as we did this, SG1, concurrency and parallelism, had so much work to do that they decided to have an extra meeting, which we held here in this area, just a few miles away, in May of last year. You know how many people came to that meeting? And this is just concurrency and parallelism, and also a few came for networking. It was a combined SG1, SG4 meeting. 40 people, which for that meeting alone was something like 80% of the previous 2 years ago normal full standards meeting attendance. Who came? World-class experts in that domain, concurrency, parallelism, and also networking, who had never been to a C++ meeting before because they thought, well, I don't really care about just the whole standard. That's too much for me. But they cared a lot about C++ and they cared a lot about that domain. And this attracted a whole set of new people to do work. The same thing happened with several of these others. Then in the summer, there was a groundswell. We saw this was working well. People said, hey, we should have one for transactional memory. That actually came out of the May SG1 meeting. Over the summer, another group for numerics led by Lawrence Crowell. And Michael Wong, who's here in the front row, is the chair of SG5, transactional memory, which has been extremely active. I just can't follow it. You've been so active. And then at the Portland meeting, or the Fall Standards meeting last year, we created 3 more. Reflection, that I'm going to start forgetting my chairs now in the bright lights and on the stage, so correct me if I get it wrong. But Clark Nelson, I believe, Chandler, where are you? Chandler, you're doing reflection. Thank you. Concepts, of course, that Bjarne and Andrew are working hard on, and Matt Ostern is chairing. And ranges that we have Marshall Clough of Qualcomm, who's chairing that. This was at the Portland meeting. Now, let's just stop there for a second. You can see we're spinning up study groups. They're starting to do work asynchronously. Now, you probably didn't notice that, unless I happened to mention it in a talk where I said, hey, look, we've got these study groups. Why? Because the pipeline was starting up. Do not interpret boxes on the screen but no product, nothing shipping that you can see yet, for no action. This is a pipeline that's starting up. You always have that delay, and then as the pipeline fills up, then you start getting lots and lots of things coming out the pipe while there's more still in flight. So this is the pipeline spinning up. Now at this point, just organizationally, can you see a problem with this, especially if our goal is to encourage libraries? Anybody spot a problem? There are no libraries. Okay, well, there are a few. Notice that I've colored the SGs that are library focused with the darker colors, so SG6, 9, 3, and 4. And SG1 is sort of part language, part library. So there's some libraries there, but what about the proportion? Yeah, it's sort of half and half. Okay. Anything else missing? So I'll talk about that, but is there anything else missing here? UI, we'll get to that. But specifically, what about the top half of the screen? What is an obvious asymmetry if we are serious about libraries? Say it all again together. Okay, so we now have a library evolution working group. So I worked with Alistair Meredith, who chaired library, and said, it's not fair for library to be doing the work on the library side that both core and evolution are doing on the language side. We're serious about libraries, and so Beeman Dawes stepped up to be an interim chair to find his own replacement. And we just appointed Jeff Ryaskin of Google to run the library working group, so he'll be doing that, sharing it personally for the first time. He stepped in Bristol when the main chair couldn't be there, and he's going to be doing it for real in Chicago in a few weeks. Now we're more geared up to be able to accept these proposals coming out of the study groups. Then we created a few more. Clark Nelson does run feature test. We have Gabi Dos Reis on undefined behavior and Bill Seymour on databases. Now, you've already mentioned one other problem. So we solved the absence of the library evolution working group. The other thing about this is I've color-coded this for language and library, and you'll still see that slightly more than half of the study group work. Of course, the study groups are different sizes, and so that's not quite right. But to an abstraction, there's still a lot of language stuff being done, right? So we keep talking about libraries, but then we keep extending the language. That's not the right way to look at it. Let me show you another way of looking at it by what these study groups actually do. And I put them in this order for a reason, left to right. More language to more library. And I want to talk about 5 particular aspects that are down at the bottom, and I'll wipe those across the screen and identify how each of these study group clusters maps onto each one of these. First, yes, they're doing language extensions. That's that first one. So you get a check mark in that row if you're doing a language extension. But the second row is supporting library building, because we need better support for library building in what is already the world's best library building language. So which study groups are also adding support for library building, even if what they are doing is a language extension, it is in support of libraries directly. Third, library composability, so you can take different libraries, put them together, and know that they'll work correctly. And then finally, pure libraries, both foundational base libraries and then domain-specific libraries, as we get higher and higher in the library level. I would give a check mark each to language extension and library building in SG7 and 12. So clearly, undefined behavior and specifying that, that's mostly a language thing. But reflection, we are missing some key libraries, such as Java processing, which people have tried to port to C++ because we don't have reflection. So that is a language extension that's being worked on, but it is in support of library building. Then let's talk about transactional memory and feature testing. Feature testing, you can say, might be about composability, but that's not the reason that I gave the check mark there. The reason I gave the check mark is because transactional memory is basically primarily about composability. The fact that mutexes don't compose. Synchronization does not compose. I cannot take two modules. And this is not just true of C++, by the way. This is a general truth in any language. You cannot, in general, take two libraries that each uses a mutex or similar synchronization internally, prove each one is correct in isolation, and combine the result and be guaranteed they won't deadlock, that they are still correct, if there are control flows in between them. One calls the other, or there might be callbacks, or if they could interact somehow, purely on a control flow basis. This is not a good scene, and our only hope on the horizon is transactional memory to hopefully deal with that. And of course, in the meantime, we have to be very careful about our synchronization. So that is also in support of being able to compose libraries. So I can test an isolation link, and I know that if A and B are correct, AB is correct. Modules, I think everybody and their kid brother is aware of. We so need a module system in C++. Yes, we have our static libraries and DLLs and shared libraries and different platforms. We need not only a standard version of that, but we need to get past the include model. And so we hope that progress can be made there. It sounds like the modules work is making progress, and there's a study group for that, which we hope it's simmering right now, and we hope will become active. That's clearly all about library building and library composability. Concepts is all about library building, library composability, being able to separately check the code that uses a template, even in Concepts Lite. Then we get to base libraries like numerics and ranges. I mean, let's just stop talking about iterator pairs and let's have a range. That seems like a wonderful idea. You know, if you have a pair of data items and there's some invariant for them, but there's no type that brings them together. There's an invariant across these two things that you're always passing around together, like iterator pairs. It shows you're missing a type, because invariants should be bound to types. They shouldn't just be floating around free. Obviously, ranges and numerics are base libraries that should be in the standard and will have a great impact. But now we're starting to talk about pure library extensions. File system is a pure library extension. Concurrency is looking at some language features as well. But it's primarily, if you look at the page count of what's being proposed, parallel STL, extensions to futures, things like that, concurrent collections and containers, it is mostly about libraries and language support in favor of library building. And finally, networking and databases are all about fundamental and mostly domain-specific libraries. Now, if you count up the colors of the check marks at the bottom, I think you will see the correct emphasis on library building, because even the features that we are doing in the language, in the study groups, there's other stuff going on in evolution itself that may not be about library building. But at least in the study groups, the emphasis is about library building, including language features to support library building, library composability. So here's an update. Since the last time we talked, the concurrency group met again in Santa Clara. Thank you to NVIDIA for hosting that for us. And in July, we decided that we're well enough along with the proposals that we put a draft, a straw man plan for technical specifications for things we think are getting close to ready to ship in the next year or two. The first bunch was a concurrency technical specification. That might be in 2014. That's a direct quote from the wiki notes and the meeting minutes. And the intention is to ship a concurrency TS, which we might be done with in as little as 1 year, that contains the stood future extensions to make it have the non-blocking part. We already have the blocking get and wait. To add the non-blocking then, wait any, wait all. The executor's proposal that Google is spearheading, and the resumable functions await proposal that Microsoft is spearheading, which is a language extension. And then that would be the core of the technical specification is the current thinking. But we're working on other stuff. And then whatever else of the bottom part of the list happens to be ready, which could include some or all of counters, queues, concurrent vector, concurrent map, unordered map, latches, barriers, things like that. So we expect most of that column, at least the first three things, perhaps to be baked in about a year, and then there's some ISO red tape. So in the next year, 18 months or 2 years, to actually have something that people can conform to and ship. And of course, I already announced today that we're shipping the await feature in our CTP later this year, so people can get used to it. Other compiler vendors are shipping other parts of pre-standard features so that we can get used to them and learn about them as we standardize. So that's one half. What is also coming, and this one does not have the date 2014 on it because we don't know yet, but what's also coming is a parallelism TS. The study group sentiment, and we discussed this for an hour or two, the study group sentiment on these, and now speaking of the parallelism TS, is that it should have at least one of the parallel algorithms, which is the parallel STL proposal. So basically think of the existing STL, nearly all of the algorithms, and being able to put stood par or stood vec for parallelization or vectorization as a parameter. Wouldn't that be cool? There's a proposal for that, and it's getting close to ready. Also, other general database parallelism and general task-based parallelism. I won't define those. If you can Google them, or if you know what they are, those are the two main models of parallelism that we want to cover. We might get all three, but as soon as any one of those is ready, the committee thinks it's worth shipping as a parallelism TS, plus whatever else in this bucket is ready, such as MapReduce proposal and pipelining. And one thing I want to make clear is this is near term. We're talking in the next year or two, we will probably get most of this. And this is not just catching up like C++11 finally acknowledged the existence of threads, which were invented like 18 months before C++11 shipped, right? This is not just catch-up. This is great acceleration to the latest state-of-the-art, state-of-the-industry concurrency and parallelism language and library features that are actively being worked on, in some cases, first in C++. That is quite a change from where we were even just 3 years ago. Now, so I showed you this group, and I want to make one more point, and I want to dwell on this for a few slides, because this is going to start introducing what I said up front was a change in our population. We have a population shift going on in C++, and this is a really good thing. But I don't think we understand this yet. Now, some of you do. I know that. But the large C++ audience often thinks of the C++ programmer as, a guy that probably has a gray beard and is of a certain age. And that is just so not true. The average age of C++ conferences and the committee itself is going down. More and more people without facial hair of any color are doing work in C++ first. And I want to tee this off by talking from this slide, because there's actually one study group we're probably going to create this month that came out of a spark by Tom Kirby-Green. So thank you very much, Tom, on the C++ MVP mailing list at Microsoft, and we immediately started including other people externally as well. And as soon as it was suggested that we should do something about standard 2D graphics, it's like everybody came out of the woodwork, and there was this silent majority that said, well, duh, of course we ought to do that. So Gore, you made that comment earlier. So let me talk about what this proto-study group that I'll probably appoint as a study group later this month is going to work on. I think this is so important that I didn't actually look around for a chair. I'm getting fairly good in my old age at delegating, so I managed to find 12 other study group chairs and people who were willing or didn't run fast enough to go and do that work. I care about this one, so for now I'm going to chair the study group myself, because this is a really important one. And I want to put in a really important reality check that we all forget. Bjarne, this is your quote. Would you like to say it? Okay, imagine me now with Bjarne's voice. No, I'm not even going to try that. Nobody knows what most C++ programmers do. Now, the context for this quote, in standards work, at conferences, at coffee shops, in beer halls, wherever people talk about C++, which is pretty much all over the place these days, every so often somebody who thinks they know a lot about C++ or have been around it for a while, or just they know 100 friends who use C++, therefore that must be all there is, and they must be a representative sample. Yes, not everybody is a stats major. Thinks but no, you don't want to do that language extension, you don't want to do that library, or you want to do this way, because most C++ programmers do X, or think Y, or have this need or that need. And I love this quote, not only because it is so true, but because when Bjarne says it, what is the credibility of anyone who might say, oh, but I think I do? Nobody else gets to credibly say, oh, but I think I know what most C++ programmers do, because you know what? If you want to think you know C++ better than Bjarne, go for it. We don't have to pay attention to that. And in particular, let me try to rattle your cage about what most C++ programmers do and don't do, and what preconceptions you might have that I had until the last month or two. Because my preconceptions were shattered. This continues to be true of all of us. Here's a question for you. If you were asked by a university, a design art studio, somebody developing a curriculum, what language would you recommend for creative graphics apps written by non-CS majors? Maybe it's a finance major or an art major or something like that. Seriously, now you have some idea of where I might be going with this. But ignore that. Like, seriously, if somebody asked you this today, what language would you tell them to go work in? What language would you recommend for creative graphics apps? Python? Python? Processing, which is?
A graphics language for non-programmers.
Well, it's a graphics language for non-programmers, but processing is based on there's processing in Java and there's processing.js, so there's two of them. Yeah. But that's okay. I just wanted to highlight the languages. So it's basically processing uses Java reflection to basically implement almost a new language on top of Java, so it doesn't look as much like Java. But yes, so that's what people would, or JavaScript, that's pretty hot these days. And of course, JavaScript is just like Java because the names are the same. What else? Anybody else? ActionScript.
I was going to say JavaScript on Unity.
JavaScript on Unity, which would be great if you're doing a game. Okay, I'm going to come back to some of these. And there are others that you can probably think of, because some of you have named game engines. Some of you have named some of the popular graphics APIs. Does anybody want to recommend C++ with a straight face? No, seriously. Put up your hand if you would recommend C++ with a straight face for a non-CS major, a professionally trained programmer.
Sutter?
1, 2. Okay, I see 2 hands. Any others over here, by the way? Wave if you see it.
Qt is possible.
Qt, okay, also known as Qt, like you said, but it's cute. And there's 2 hands here, and somebody shouted Cinder. Hold that thought. I want to show you a video of an application. And at the end, I'm going to ask you what language it was written in. So you already know this answer. This is not a trick question. But I also want you to think about what would it take if you were told when you came home to work on Monday after this conference, hey, we should build that. What kind of team would you assemble? How many people? What kind of people, programmers, artists would you have? How big a team do you think you'd need to do? What language would you pick? What libraries, frameworks, tools would you pick? Let me show you in a video, and just give me a second to move over to it. And I want to show you what the application is for a minute. Let's watch.
We're excited to introduce you to Planetary, and all-new, stunningly beautiful way to explore your music collection. Planetary is a visual music player for the iPad. Artists are stars. Every star in Planetary represents an artist from your music library. Albums are planets. They orbit around their artist's star. Tracks are moons. They orbit at a speed based on the length of the track. Bloom, pop cultural instruments for data expression and exploration.
What language is that developed in? This is the gimme question. C++, of course. Okay, people do know that AAA games are written in C++ very often, often using an engine that's developed in native code because of the performance and flexibility, etc. This is not a AAA game. It may look like one, but it's not a AAA game. How many people do you think, let's ignore artists, how many developers do you think that you would want on a team to build this app, which, by the way, is a 2-year-old iPad app, but I'll tell you a bit more about it in a second. 2? I heard 3. Do I have 4? 1. Okay, 1. Okay, so 1, would that be like Dave Cutler? Like, are you talking about some super guru 1? So tell me about this one developer you want to hire. No, seriously, what are the requirements? Who are you looking for? Tell me about him. Graphics, okay, if you're going to put it on the developer, you want the developer to have graphics design too. That would be nice, although those are usually separated. But okay, graphics design. But let's talk about his development skills. What's his resume look like for his development chops? Okay. I'm hearing a few different things that talk about platforms, that talk about certain tools. Do any of you know who built this? It wasn't just one guy, but I'm going to tell you who the primary developer was. So Planetary was written, surprise, surprise, in C++. It was an iPad application that's been out for about 2 years now, just had a nice 2.0 update with some cool new features. But most of this is creative stuff. Like this is done by a creative person, not just somebody who's writing code necessarily for a living. In fact, this was written primarily by Robert Hodgin, who's a self-taught programmer, completely self-taught programmer, and a sculpture major at the Rhode Island School of Design. Nobody knows what most C++ programmers do. And we are seeing more and more, especially in the creative graphics world and in other domains, of people that you might never expect to be a C++ programmer, who are not even professional programmers by training, but who are learning C++, and C++ is doing great for them. C++, people think, is this arcane, hard language for these gurus with gray beards, right? We know intellectually that C++11 has made things simpler and C++14 continually, but we can compare it side by side with what we know about the complexity of other languages, and we can say, nah, it's still more complex. I don't think beginners could ever learn this. Bjarne has taught hundreds of students in CS 101, first-year students, C++, and we have at least 3 books, thousands of students, successfully, by the way. People are gobbling them up, and you have a book about that. Programming Principles and Design in C++. Andrew Koenig and Barb Mu, Accelerated C++ is another book for beginners, and Francis Glassborough has one as well. But we discount C++ as an introduction to programming, and we shouldn't. Did you know, let's talk about creative graphics. Did you know the C++ library Open Frameworks is a de facto standard teaching library in creative graphics and design schools, like the Parsons School for Design up in the Northeast, one of the largest and most prestigious design schools in the world. They use C++ and Open Frameworks to teach their artists how to realize and sculpt digitally the creations they want to build. Cinder, some of you mentioned Cinder already, which was used to develop this application I just showed you, was just awarded the advertising industry's highest honor a few months ago at the Cannes Festival. Now, it wasn't George Clooney. It wasn't Sandra Bullock. It was a C++ library that got a Cannes honor. Like, you don't normally think of those two, Cannes, C++ in the same sentence. They just don't seem to fit. They're not photogenic enough. They don't wear the right designer Armani jeans. But that was what happened in June. And the app I just showed you, Planetary, also just last month was the first of its kind to be adopted by the Smithsonian. The Smithsonian Institution has never curated code before. They curated to preserve this application as the first of perhaps others that they will also curate, and immediately open sourced it because they realized the importance of curating coding milestones like this. C++ app curated by the Smithsonian Institution. And I could give you more examples, but this is being done by non-professional programmers who are being very successful in C++. And here's a quote by Andrew Bell, one of the lead folks in the Cinder community, which summarizes this. The advertising and design industries have really embraced C++ in recent years for a whole new generation of interactive projects. This is important for us because who doesn't want to have the coolest new tablet and phone app? This is what they're using. He continues, I think that's largely because in our work, a piece of software's performance often marks the difference between a user's experience feeling ordinary and feeling, here's the word, magical. This year has been an excellent year for C++'s visibility in the art and design worlds. Who knew? Not us if we were just slinging backroom C++ code. But we are seeing this change in population where C++ is appealing and being used by a very diverse group of people. Now, here's a slide that I stole from Bjarne. He showed this yesterday. So yesterday he said, what did or do I want C++ for? And I'm highlighting the part in the bottom left because he said he wants it for experts. C++ is expert friendly. This is true, right? Look at any slide by Andre, right? C++ is definitely friendly to experts. We welcome them. We love them. But also novices. C++ is not just expert friendly. Now, tell me the truth. And you don't have to answer out loud, but answer in your minds. When Bjarne said that, how many of you kind of were saying, oh yeah, maybe somewhat, but you know, he's overselling it. C++ will never be for novices. Well, you're wrong. We just demonstrated that. For self-taught programmers who have sculpture degrees, it is doing just fine. By the way, did you notice something else? I just have to show it. How many of you noticed that there was that Bjarne had at least 63 typos because there was one typo that appeared on every page of his? Yeah. You saw it? Where is it?
Going naive.
Yes, going naive. Isn't that great? Now, I have good news and bad news. The bad news is he's fixed it. So by the time you see this talk, his talk on demand, and download the slides, the wonderful quote will be gone. But it will be preserved here because I am not going to update this slide. And I think it's incredibly apropos. It's a hilarious typo that actually works with making C++ not just expert friendly. Let's go naive. Like, why do we expect rocket scientists to have to think hard about templates and angle brackets to be doing C++? It's just so not true. So how easy is C++ really? I have a couple of demonstrations, but first, I was sitting in that seat beside my dear friend Scott Myers. Thank you, Scott. And he happened to look over my shoulder. It was during somebody's talk. I was just tweaking with my slides or reviewing them. And he looked over my shoulder and he saw this. And he leaned over and he whispered, is that on a scale of 10 to 20? And so I whipped up this slide immediately, showed it to him, and he winced, and he said, I did not say the new line. But people think this, right? Okay, you start with difficulty level. If this is 0, you start here at a C++ programmer, and the sky's the limit, right, for difficulty. Let's talk about a 15-line of code example that will be familiar. Let's start with something familiar to us here. We have some includes, 4 lines of includes. This is a 15-line of code example. I'm going to wait now while you count the lines. Okay, do we agree it's 50? Okay, because I know you're doing it. So now that we're all back, and no, I am not counting the empty brace on its line, something with an alphanumeric character counts. This 15 line of code example has nice resource management, automatic resource management, console input and output. It asks the user to please enter some numbers, while in Andre's approved form and Bjarne's approved form, while sin /shift-I, VDA pushback, and then cin, the result of the operator returns false when you're done. Then we sort. Look, a standard algorithm. Let's see, where is he? Sean, you'd be proud. I need to use rotate more, but I use sort here, okay. And then here I print the numbers sorted. Now I use cout. This is a simple 15-line of code example that you might find in something like accelerated C++ that people can get into. How exciting is this? How many of you are like really excited by this? Okay, STL put up his hand and yelled, "So awesome!" And Gore, the person who a half an hour ago was saying, "We need a graphics library," put up his hand saying, "Yeah, that's cool." You should not be satisfied with that, Gore. I'm very disappointed. You were right the first time. So, as we talked about a graphics library for C++, so this is to tee up the conversation we've been having in just the last few weeks, it turned out there was this critical mass to do better. And I think it was Tom Kirby-Green in particular who said we need to get past the, anybody recognize this? VT100. We need to get past the VT100 era of programming, where you have basically a teletype. You know, I wish it was that good. How many of you used a VT100? Okay, there are a few people with gray beards. Okay. It might have been in the Computer History Museum. I'll grant you that. But let's take a closer look, because the sad part about this is that C++ program, standard C++, cannot even exercise the capabilities of a VT100 terminal, which had underline and bold and inverse text and double width text and double height text, which I did not see with an std::: prefix anytime lately. Standard C++ is not even able to drive, in pure portable C++ code, is not able to even exercise the capabilities of a 1970s era VT100 terminal. So we're actually doing it a great compliment by calling it VT100 era programming. Now, having said that, just like the standard didn't have threads until 2 years ago, fine, but we still use threads all the time, just in non-standard ways. But why on earth can't we write portable code that talks about threads, parallel algorithms, and a bit more than this? By the way, if you look at the bottom right of the screen on the keyboard, what are those 4 keys in an extra row at the top? Cursor keys. Don't got those either. At around the same time, I've been dying for years to put this picture on the screen, so I'm going to succumb to the temptation today, because this was my first love of the electronic kind. I guess we had a Commodore PET at school, and my friend had a TRS-80 that he let me write programs for. But this was the first computer that I ever had on my own. It was built in 1979, an Atari 800, with a whopping 16K of RAM. And at the time, I thought it was great. I wanted to have the best computer, so I also bought a 32K expansion card for like $700. And later discovered that that doesn't mean every application can use it, but it was a nice piece of hardware that sat in there unexercised. I loved this because I could make it do stuff. I could write games in this. I wrote a little mind-digging game, other kinds of graphics maze games. And it was so accessible. It came with Atari Basic. And you had text mode. So some of the games were text mode and some were graphics mode. In text mode, you could get or set at a location. You could have graphics modes where you had double width and double height, just like the VT100. That's in text modes, rather. In the graphics modes, you could get set pixel, you could draw lines, just basic stuff. But you could do creatively great things with that, especially if you think you're 15 years old or something. It seems great. I think 13 at the time. And it went up to a whopping 320 by 192 at 1.5 colors. And the reason it's 1.5 colors is because that was actually more columns. That was twice as many columns as the TV had that you connected to it to the output. So the odd-numbered columns would be one color, and the even-numbered columns would be another color. And you could sort of fake colors. It was otherwise a monochrome mode, but you could fake colors in practice by doing half of the color clock each time. And of course, the colors would change on different hardware, but that was okay, because this was so cool. So I used Graphics 8 quite a bit, which was 320 by 192. It was fun to code against. Our business in C++ is exploiting the machine. It is our bread and butter. There must be no room for a language lower than C++. Yet standard C++ cannot exploit my 1979 Atari computer. It cannot do graphics. It cannot even do 2D array of characters to get instead a character. We need more. So now let me ask that question about how easy is C++ really. I showed you a 15-line of code example that did console input. Give me some numbers, sort them, and print them out. Now let me get, are you willing to give me a whole another 3 lines? Sure, okay, I'll take that. First offer, always take the first offer in cases like this. Permission, right? Here is an application that you can download as a sample. It has a DX prefix. That's the DirectX version that works as of May for Cinder, the library Cinder, with tablet apps on Windows and Windows Store. There also is the GL version, which has existed for a couple of years. So change DX : to GL : basically, and you're using the OpenGL version. And you can run the same code on Mac. You can run the same code on iOS, Windows Metro, all of those things. There are a couple of points I want to make about this app. First, let me show you what it does. So I inherit from this app basic. That's just the way Cinder lets you plug into their default game loop. We call it a game loop, but it's really a graphics loop. So you can customize your own, but usually you just will inherit from this. I have a standard vector of 2-dimensional points that are floats. On the mouse drag event, I simply get a mouse event, and it has, look, a dot position. So I can say pushback on my vector e.getPause. 1 line of code. It should be that easy, right? It's just a mouse XY position. And then in my draw, because this is an immediate mode. Immediate mode means I write the code myself to draw on this patch of pixels every frame. There's also retained mode where you build a scene graph, and you sort of at a more abstract level describe what your scene is and where things are in position, relative position. And then the system projects that into an immediate mode under the covers. But this is just using immediate mode, just like my old Atari. It's just scribbling on the screen. So when I draw each frame, I just simply clear it. I set the color to what I want the line color to be, which is sort of orangey. I begin an OpenGL line strip. For every point, I put in a new vertex, and I say end. And what you get, this is running on this machine. I took a screenshot of it. So I built this on this machine, on my Surface Pro. And I immediately used, not a mouse, but I immediately used my stock pen that came with my Surface Pro. And I wrote in Herb script 192 point or whatever that is, that's me with my pen writing hello. Why can't that be a hello world for CS 101? What do we need console for? Yes, you also want console I/O. You also want to put text on the screen, but we can do that too. Now, I want to make a couple of points about this. First of all, this is not a program excerpt that fits on a slide. This is a complete buildable program. This is the complete source code. If you're wondering where int main is, it's under the Cinder app basic macro in the last line. This is already de facto portable across several major architectures: Windows, Windows tablet style apps in the store, iOS, Mac OS, I believe Android. You might have to change DX to GL, but it's already de facto portable code across all of those. It uses pen input. It's just like a mouse. That's good enough. I could do some writing. And there's one more thing I want to say about it. If you think C++ is hard and doesn't compare well to other languages, this is C++ code I would be happy and proud to show side by side with the equivalent code written in any other language. Yeah, I'll apologize for a couple of hash includes. Get over it. It's clean, simple code. Yeah, hash include, that's just boilerplate you do. And then everybody forgets about it. It's clean, simple code that works and does automatic lifetime management and all sorts of other good things for you. But the nice thing is, you don't need to know. Now, I kind of want to know for myself how things work. So how easy is C++ really? That was an 18-line of code example. Let me show you a 200-line of code example. It's actually not quite 200 lines of code. It's a little under, but 200 is a round number. So it's about 10 times longer than that. And it's here. Here in Visual Studio, I have a little application I wrote in Cinder because I just wanted to say, okay, what could I do in an afternoon? So I decided to take an afternoon's worth of time. I didn't do it all at once. I took an hour here, 90 minutes there. But I said, in one afternoon's worth of time, 4 or 5 hours, from scratch, I had never seen Cinder, the API itself, before. I'd only heard about it a few weeks ago. So those graphics people there, I'm behind the times, but I'm trying to catch everybody else up too for you. That's including the time to download it, to learn it. Note to Cinder folks, your online tutorials are pretty good, but there are a couple of glaring omissions. Send me mail. And some of the API is rather sparsely documented. But that's okay. There was enough to learn. And Andrew Bell was kind enough to help me with one support email when I had to ask, after I'd wasted one of those 4 or 5 hours trying to figure out how to put a texture on the screen and discovered it was just a bug with an interaction with OpenGL. And then it fixed that. But that was, so even burning an hour, here is 4 or 5 hours worth of stuff. So all I did was, from scratch, built an application from scratch, downloaded Cinder, said, okay, what can I build? Okay, I want to do keyboard events. I want to have a texture for the background. I want to draw. So I learned about set window size and clear. I learned to draw a board. I'm just using basic things like draw solid circle. You'll see that here, draw solid circle. I'm adjusting screen positions because I'm actually supporting zoom in and out, which wasn't in the original game. I move the player. Let's see, what else do I do? And I figure out his size because I might want to flash his size depending on whether he's eaten a power-up. And I push back. I draw the player by hand, just decided to. So I just actually create a polyline, and that's how I render the player. And that's it. That's all the lines of code right there in the main game loop. And what is this? Well, let's build it. Let's see, where's F5? Let's run this under the debugger. And, oh, here he is in this screen. Let me pull him over where you can see him. And so here's the little game that I wrote. And this is under 200 lines of code. Notice that I actually do the power-ups, but I haven't bothered. In my afternoon, I didn't get quite to the ghosts. So I figure it would probably take me another afternoon to finish the ghosts and to make the rest of it and show score updates as I eat a dot. But most of it's there. So I'm probably more than halfway there to a finished game. And I figured I just want to see how far I can get in an afternoon with Cinder, having never seen it before. So that's what I came up with. And from scratch, now, well, thank you. But I'm actually nervous because I think that probably half of you at least are better programmers than I am. You can hold large code bases in your head. I spend most of my time with small examples, test harnesses. This is 200 lines of code. I mean, it's not some huge source base right now. It's not a million line of code source base. There are geniuses in the room for this, not just John and Chandler, but a lot of you. In particular, I know that there are several dozen of you here from the game industry who probably were going, oh, that's such a cute little toy. Look at the little guy. He did that all by himself. Yeah, well, I was happy. But I really wanted to treat myself as a novice because it's very hard to think like a novice when you're an expert. It really is hard. So find a domain where you are a novice. It's a really refreshing experience. And see how easy is it with just the libraries that are out there today that just got a Khan honor. So here's the line count. 9 lines of include and using. That was actually 5% of the entire source code. 34 lines just for the data to show the initial board state. 86 lines for the game logic, for doing the turns and what to do about eating dots and power-ups. And 60 lines of graphics and input. That includes the board display, the player animation, power-up color flashing, warning transitions when you're about to go out of power-up mode. You start changing color and go big, small, and then you're small again. So I have something to ask you. How many people here are software developers? Right. That's why we're here. That was the gimme question. How many of you brought a compiler? So how many of you have a laptop with you that has a compiler installed, or a laptop or a tablet that can remote desktop into something that does? More hands just went up. Now, I just got to know, so I'm going to throw in another question. How many of you have used it already, this conference, to test something that somebody said on screen, or just to write something, or just because you were working on your code from home? Okay, so like half of you. This is what I built from scratch in an afternoon. Ghosts weren't animated, but the basic game worked. I have a challenge for you. You're all developers, and you're grown-ups. What creative graphics app, doesn't have to be a game, Feel free to do Pac-Man again and do it better and show you can do twice as much in 5 hours. That'd be great too. But it doesn't have to even be a game. What creative graphics app can you build by tomorrow lunchtime? Use your favorite compiler in target OS. I don't care what it is. If it's Windows, iOS, Android, Mac, Linux, whatever's graphical, X Windows, sure, like go for it. Use your favorite compiler in target OS, but I only have 2 requirements for you. It must be from scratch, empty project, from scratch, and you must use only standard C++. If it's not in the ISO standard, you are not allowed to use it. You are not allowed to include it. You are not allowed to call it, unless it's called Cinder or Open Frameworks. Pick one of them, Cinder or Open Frameworks, and show me overnight what you can build. Email, if you choose to do this, it doesn't have to be a lot, but I'm curious what you come up with in the next 24 hours or so. Email your name and screenshots and video to Charles, and I think I got your name, your alias right, ctorre@microsoft.com, or to me if you forget his email address, because these slides won't be up until the talk goes online later. You can find Cinder at libcinder.org. You can find Open Frameworks at openframeworks.cc. Oh, and by the way, if you're running on Windows, you would like to use the DX version, I made a note, search for Cinder site:/msdn.com, and you'll find the DirectX version, which is a branch in GitHub that you can get that works with DX. Send us a screenshot or a video, can be like an AVI or something, a video that we can show and bring you up for a minute or two to tell us with the microphone about this app. I am curious to see what you come up with. Consider this an invitation, not just a challenge, because I think it will demonstrate there is a lot we can do very simply, and there is no reason that something as simple as this Pac-Man, why wouldn't that be something that you ask CS 101 people to do in their first 2 or 3 weeks of programming? Why wouldn't you? That's a first few weeks, maybe a month, of a project that you can get new people who aren't programmers to do in C++. I'd like to thank Rick Barraza, who's in the room. Can you wave where you are, Rick? I saw you earlier. There you are in the middle. Thank you. I'm stealing these slides from him because they made such an impression on me that I wanted to share them with you, and I will not be able to do justice to them as Rick does, but put up with my imperfect rendition. And I asked Rick, did you come up with this metaphor? Because it's a really good one, and he did. So I really appreciate it because it talks about different kinds of graphics libraries. And he talks about Legos versus clay. Many of the graphics libraries you're used to, whether it's XNA or some of the Unity game engines that are very specific for a certain kind of structured app, they tend to be on the left side. Object-oriented, reusable, repeated, dependable, very structured graphics libraries. You can plug this kind of component in this way. But once you start reaching the boundaries, you're sort of limited. You can work wonderfully in this area, but it's hard to sort of be creative and free-flowing beyond what was already laid out for you. On the other hand, clay is very free-form, expressive, exploratory. We've all done Play-Doh at school. We've all done graphic apps that are lines and circles, and yet we can do so much with them. So here is the wonderful slide of all the things you can do, include up to a dress. That looks very uncomfortable, with Lego, including, I like the Kraken, the KRKN, Rebel Alliance, with the Star Destroyer sticking out of its head. That's the normal-sized Star Destroyer. That's Darth Vader's bigger one below that it's wrapped around. And you can do a lot of stuff with Lego. I enjoyed Lego as a kid, too. And I know that's not just for kids. You can do RC stuff with Lego. But you build what they give you. It comes in kits. It comes in specific forms. And there are limits to how you can put it together and the things you can express. You can make something that looks like a dress, but it may not be what you'd come up with using other materials. When you're a graphics artist, when you're a creative person who is not necessarily a programmer first, you often work in clay. And clay is a metaphor more generally for malleable and flexible things that let you experiment. That, down at the bottom, right, if that thing you just made with Play-Doh didn't turn out right, you just rub it and you start over and do something else, right? That's what you do. The potter, just with the clay, he just reshapes it again and builds something else. And you can do a lot in a very unstructured way if you're a creative person with clay. This has analogs in the software world. I mentioned that there are many technologies, and I listed a couple, that are very structured. They're very Lego-like, building blocks that you can build great things, but kind of only if you use the prescribed blocks. right? So game engines are great, but they're for writing, like the first-person action game engine is great, but they're for writing first-person action games. Flash really was one of the first technologies that gave you the flexibility to be a creative coder in clay. Very simple primitives, but you can just start putting stuff up on screen, putting lines and circles and pixels up on screen, putting textures up on screen, and see what happens. This is the level that I wrote the Pac-Man app on. Since then, some of you already mentioned processing. So I mentioned processing in Java and then also processing.js. But notice who else is there? Open Frameworks and Cinder. As we moved from Flash, by the way, this is Rick's slide, so that skull thing there, that's I don't know, that's his. I'm not making any statements, I'm just borrowing the slide. Ask Rick. The reason that they moved from Flash to processing which is a Java framework, is for performance. One of the reasons, performance and flexibility. Yes, choosing Java for performance and portability. Well, if that's your motive, where do you think you'll end up? Well, then we went to Open Frameworks, which is a C++ library. Processing was also available on JavaScript, and now we're at Cinder, a C++ library. And what distinguishes this progression from other technologies that have come up in the time, which are also useful and good, is that these are unstructured ones. They are more clay-like. They give you much more direct access, just like my old Atari, to just put pixels up on a screen and see what happens. And that is immensely rewarding. And one of the reasons, remember I showed you that 18 lines of code where I could just with my pen write hello? It was a very simple Cinder app in 18 lines. What was most important to me about that was it was seeing that 18 lines, compiling it and seeing it run. I could actually write my name, or write hello in that case. The one I showed you, first you write your name first. And then I wrote hello. That's what made me want to write Pac-Man. Because I saw how easy it could be. It made me want to do it. And I haven't written a video game in 30 years. That's my first video game code I've written in 30 years. Which is too long. Must do it again soon now that I know how easy and fun it is. And just from scratch. And having an accessible library where in a few lines of code you can get started is an incredibly drawing and enabling experience. So as we're getting organized with our 2D graphics study group, we still haven't had an organizational meeting. We've just had a conference call and some discussion on the reflector, the new DL that I created. This could change, but here's the draft proposed initial scope. We do not want to be an all-singing, all-dancing GUI WIMP widget library. No thank you. We don't want to be a portable a platform in its own right, but a thin wrapper around what's already portable. 2D graphics with a modern C++ 11.14 API for 2D and text. In the future, maybe 3D, but this shouldn't be something where there are training wheels you have to abandon to do something real. It should be something that I could run today, and then as I have more demands, like maybe I want to have a 3D application, I'm running through a maze or whatever in 3D, I should still be able to use this 2D API as a heads-up display, for example. It should be open to extension in those ways, and potentially in the standards area as well. But for now, 2D plus text. Immediate mode. I talked about retrain mode, where you actually have sort of objects in a scene that it gets rendered for you. Just immediate mode. Just let me draw pixels. And maybe have some support for a particle engine and sprites. By the way, it turns out that a lot of people are thinking this way. Apple has announced Sprite Kit, and the only thing we know about it so far, if you're not under NDA, which I'm not, is that it's basically sounds like this. So a lot of people see this as a sweet spot for doing graphics in a portable way. Have a default graphics loop that's optional, because as people grow, they'll want to write their own, but they want something simple to get started, just like I showed in the Cinder app. Have a native handle hook to write the non-portable bits. This is really important and really simple, because it lets me write in portable, I hope soon, standard C++ graphics code, and still be able to dig down and reach the platform-specific goodies that I want to. This is what C++ is for. And a hook similarly for integrating with your asset management tools. The major graphics libraries, if you're on that list, we've reached out to you or are looking for your email address. We've heard back from most of these already, and as we now get organized, these are the people who are going to be working on approximately this. And I think it's really important to make C++ accessible. So last year I talked about pickle scope, and I said, hey, here are some of the lower level and higher level libraries that we would like to have. How are we doing? Well, the green ones are ones that have active study groups or have serious work beginning on them, either early or well along. File system is well along, it's almost ready to ship, and audio and video images, graphics is just getting started, REST web services somewhere in between. So we're making progress on most of those, on track for inclusion potentially in any future standard, but as part of the standards process already. So we'll keep working on that. And I promised you one slide on the next outer piece. What about de facto libraries? I hope to give you an update on that again at some time in the future. Our thinking is evolving there too. We have very few libraries that somebody could write a book and just assume people have that aren't part of the standard. The core of Boost is one of them. But there's not much beyond that. You still have to find it and download it, install it on your own. They're usually not bundled. Boost is sometimes bundled, but they're usually not bundled with the compiler. Wouldn't it be nice if we had a PyPy plus an apt-get for C++ libraries? A way to discover a catalog that gives you filtering, reviews, to find C++ libraries, filter by platform, by what company, what platforms they support, what quality level users think they are. Acquisition, to do the package management installation that integrates with modern tools. We have a little bit of this today. On Mac, we have Mac ports. With Microsoft, we have NuGet, and there's a talk tomorrow telling you about NuGet for C++, which is doing this, but only in VS so far, and only for some C++ projects. There's some nascent technologies here. One of the other things that we're looking at doing is seeing how far can we push this? Is this ready to generalize? Because wouldn't it be cool to have a PyPy plus apt-get for C++? Let me leave you with one last thought. And this is on the trajectory of C++. The sad truth is there's never been such a thing as one C++ in the world. When you say, oh, I use C++, you've always had to say, well, what compiler? What platform? Because not only do compilers have different bugs, because there'll always be modulo bugs. So assume everything I say is modulo bugs. They get lower, but there's always going to be little gotchas. But in the main, could you write portable code in C++? Sure. But how do you do it? By learning the idiosyncratic overlap of the parts of the language supported by the compilers that you happen to be using today. I love Andrew Tannenbaum's quote, which I confirmed with him because it's attributed to many other people, but I actually emailed him and he said, yes, that's my quote, feel free to use it. The nice thing about standards is there's so many to choose from. And you can replace that with de facto implementations. The nice thing about implementations is there are so many to choose from and they're so delightfully varied. I know. You know that we're now catching up and we're targeting full C++ 14 conformance, but there's still a difference. If you're writing code for GCC or Visual C++, what works where? That's been a historical issue with C++ for its entire life. There is the standard, and there's what people actually ship. So there's a delta between the standard and the implementations. And there's a delta between two implementations. Even if they're trying to conform to the standard, they may implement different features at different orders or different versions of the features. So in the early days, 1980s to 1998, we had the pre-standard Wild West. What is this STL thing I heard about in 1995, but not for the first decade of C++? What's your template instantiation model? Not just your semantics. Completely different models in Borland and other compilers. And so we converged on those and actually had the first standard in 98. And it took us 5 years to achieve partial convergence, where compilers implemented basically over those 5 years, the major compilers implemented most of the standard, minus a couple of controversial features that some of them were never fully implemented. And no, I don't mean export, because export was implemented once and shipped, as far as I know, by one actual vendor, Intel, under a switch. I could be misremembering if there were others. Now, I'm actually thinking of the hoisting of the C standard library from or to namespace std, because the standard said do it one way. Everybody did it the other way because the one way the standard said was basically unimplementable. And the users were forced to write non-standard code because in some cases it mattered. Then from 2003 to 2011, in those 8 years, we incremented X in C++ OX, and X was 7. Then it was 8, 9, A, B. I think we ended up at B. And Along the way, with this monolithic release, compilers implemented different versions of features in different orders. So when we ship the remaining part in Visual C++ of our value references, that will be the 4th implementation because we tracked it early. So you take your lumps when you're among the first to ship a feature, and the committee is still tweaking it. And now in these last 2 years, we are approaching a first convergence in those 2 years, digesting this decade-sized package of features once it stopped changing. I really want to congratulate GCC and Clang because this has been a landmark summer. May 31st, GCC 4.8.1 shipped a complete C++11 language implementation, beating Clang by days, who on June 5th shipped Clang 3.3 with a complete C++ language and standard library, too. Would you like to give them a hand? This is great for the C++ community. And thank you so much. Many of the folks who worked hard on it are right here in the room in the front row and sprinkled throughout the audience. And GCC hopes to also have a complete C++11 library in 4.9 because they didn't want to take the breaking changes for basic string and things like that in a ... release. But now let's compare what this means for the C++ industry, because there's something important to observe about trajectory. When we shipped the first standard, it took 5 years for somebody to even achieve checkmark conformance. And that's with an asterisk because I don't believe there was ever a shipping fully conforming implementation of C++98. Many got close, and if you ignore 2 or 3 features, there was a de facto subset. But it wasn't the standard, and you sort of had to know viscerally what it was. C++11 is the first standard that has a complete implementation modulo bugs. And that was with Clang a few months ago. Soon to be joined by GCC in the spring, probably, I think. I'm not making product announcements for them. I'm just asking them every so often, and they're kind enough to share, yeah, this is where we think we are, and they have public status pages, so that's what I'm reporting. And what's unique about C++14, which we expect next year, it seems like that will be the first time in the history of C++ where this year was the first time in the history of C++ we had a fully conforming implementation. It looks like next year we're going to have, for the first time, multiple fully conforming implementations of the standard in the same year it's published. This is an incredible convergence in the C++ community. And let me just go back and recap. In 2013, 2 major language implementations, fully conforming. We expect early next year GCC and Clang to be fully language and library, completely 11 conforming. And in 2014, maybe early 2015, maybe it might go into 15, that we get at least more than 1 full C++14 implementations. Now, these are my personal estimates. They are not official. Clang, I observe, is releasing every 6 or 7 months, and June and December. So they seem on track and likely to make 14 and 14 because of where they are. Unless they just choose not to implement something, but I don't know why they would. You'd be crazy. GCC is releasing every spring, so if they keep that up, I would expect that next spring in 2014, they would ship 4.9. We know that they expect to have a fully conforming 11 standard library. Don't know if, and they're working on some C++14 features. Don't know if they'll get all of them by then, but if not then, on that, if they keep that cadence, it'll be early 2015 where they should be, one would expect from looking at the trajectory, fully conforming to C++14, a few months after the standard itself ships. Visual C++, I'm not announcing an ETA, but we have said we are targeting C++14, including the TSs, including concepts. And from the roadmap update I gave you, that is the best we know today on our trajectory, so you can sort of extrapolate yourself. But we hope to be not too far out of this crowd, and so we'll keep you updated when we know more. If I knew more, I would tell you today. I don't know more. But we are absolutely clearly seeing this convergence among implementations. Until this year, the world has never even enjoyed one of these. This year we got the first one of these 3, and we've still never enjoyed all 3. Multiple consistent C++ products where I can write the same code and just know it will work modulo bugs on every major compiler. Where that common subset is the standard, the full standard, which has never been true before. And in the same year that the standard is published. And starting in about 12 to 18 months, that's where we're going to be. And it looks like this could be the new normal. As The standard ships more frequently in smaller batches. We're shipping pieces asynchronously as TSs that people can implement and experiment with, which reduces risk in the main standard, which is good project management. And as the C++ community is aggressively implementing and absorbing those features, but gradually. So it's not big lumps once a decade, but we're gradually getting goodies in a way that really broadens the scope of C++ developers beyond the graybeards to young and hip, to the graphics artists, to the non-professional programmers, where C++, it turns out, is already a language of choice in graphics art and design. Who knew, unless you were in there? C++ is very horizontal. It's being used in many ways. And we're looking forward very much to seeing this convergence and this big change in cadence, in unity, and in population in standard C++. We'll keep you updated. Very exciting times. Please take a break. Thank you for coming. And then come back and don't miss the rest of today's conference. Thank you.